Hello, everyone. Nice to meet you again. And now it's another week. It's just such a hectic week. So, what we are going to do today is continue the business object discussion, and we're looking at a very big topic today. It's called schema. Okay, so yeah, let's start. Hello. Okay, let's start to talk about the BO schema. So remember last time we were talking about these four features of business objects. I made a word. It's also right. The algorithm, life cycle, schema, and options. So schema is the first topic we're gonna talk through. So I can see there are quite a lot of things we need to talk through today in schema. Break it down into five sections. First one is about physical mapping between business object to the database table fields. Second, about flattening element. Third one is the element types. The fourth one is I'm going to talk through the grouping and also the list. And number five, last one is CLOB. Okay, start with the physical mapping. So here we can see an example business object schema. It's quite simple, six fields about look like a person. Basically, what I'm trying to show here is every BO has a schema that defines its element. In this case, it's just a simple level. And for each of the elements, it is surrounded by this quote. So it looks like XML style for a schema. If we look at the database presentation of business schema, as I always do, I would like to map our metadata into the actual table because sometimes you would actually want to investigate in terms of doing some query and to look at what is actually behind this metadata. Now, if I look at this BO schema, the first thing I would notice, the business object is contained within a table called F1 business object. And the metadata collected is the CIMD MO. So CIMD, remember this prefix is the metadata tables. You will see quite a lot in the following slides and the future videos. So the first metadata is the MO, and then the MO collects a list of tables, and the tables is mapped to the metadata tables, which is CIMD table, and metadata table contains a list of metadata fields, and the metadata fields is also mapped to the fields in this loop. Okay, so for each of the maintenance object, it has one and only one primary table, and the mapping rule for the the elements in BO to map to the columns on the primary table is using map field. Over here you can see the taxpayer ID is actually mapped to the per ID, which is a column on the primary table of looks like a person MO. And then for each BO, it must also have elements mapped to the primary key field on the primary table of MO, and that's using the is prime key equal to true in the attribute. So over here you can see the taxpayer ID is mapped to the prime key, which means the per ID is the prime key of the per table, CI per table. Okay, so moving on to the second part, flattening elements. We have just seen two examples, which is map using the map field to map to the primary table. Now let's have a look at the other examples. So in this case, we want to map the fields in the child table column. Okay, so if we look at the example here, we are trying to map to three attributes mapped to three different child tables using map child. Over here on the right hand, if you have a look at this diagram, we can see person is the prime table, and per ID, person phone, and person characteristic, they are all child tables. However, you don't have to have the exactly same structure in the BO schema. So in the BO schema, you can see the taxpayer ID, name, email, they are on the same level, although you can map different elements into different levels. For example, the child tables for some of the fields. And the way to map it, as I said, it's using the map child, but it's also using the keywords like is equal, which uniquely identify the row that holds the element's value. And also it's used the default equal, which defines the default value. So we look at more examples. Now, let's have a look at another example which actually simplify the mapping multiple elements to the same row. So in this case, we have a work phone, which is mapped to a child table CI per phone based on the phone type is work. Okay, so which actually means the work is a key attributes of this child table. And at the same time, we want to say for the records above, for the work phone column, we want to add the work extension on the same record. And in that way, we can use a keyword called row ref to apply to the record above in the same schema. So you don't have to define all these criteria again. You can just do a reference row to refer to the one you have just used. And over here we can see the same thing can be applied in any child table as long as you have this kind of relationship required. Right, so the next one is about effective date. Now, not all the child table would have effective date, but the most noticeable is the characteristic table. And characteristic table actually applies to a lot of the MOs. And in this case, we have, if I read this schema, I can see the risk category element is mapped to the column called ad hoc travel in the child table CI per char, where the characteristic type code is risk cat, and the effective date is defaulted to current date. Okay, so what I can see from this definition is if I insert this value, if I submit the payload the first time, I can actually create a row in CI per category characteristic table with the effective date of system date, and the value is whatever has been specified for this risk category. However, if I submit the second time for the risk category, let's say the category changed from A to B, the row will be updated rather than there is a new row created, because it is always mapped to the characteristic type of risk cat. So that makes it unique. Because the default is current date, and on that row there is already a date, so the date is not updated, only the value is updated based on this definition. Now, if we actually want to update the characteristic in the payload, what we can do is, for the risk category, we can refer to an element in the schema. So in this case will be risk edate, for example. And the risk edate is an element where you can specify the value as well. So every time you submit this payload, it makes it unique. Then there will be multiple values to be inserted. And if you want the system to be inserting the value only, but every time you want to have a new effective date as a system date, what do you think we should do? Right, actually the quickest way is on the risk edate, we will add attributes called default equal to current date. So in that way, you don't have to specify risk edate every time, because it would just take the system date every time. But in that way, you could create multiple values. Okay, so another example is on the language table. Language table is a bit special, so you don't have to use a map child, because language table is actually treated as a flattened element, and it treated the column as a parent, the primary table column. So in this case, you just map field to description in that case. Although physically, language table is a child table. Right, so moving on, part 3, element types. Okay, so now let's look at 3 different ways we can validate elements in the schema. So the first one is data type, second is MD type, and the last one is the FKref. The data type and MD type is a bit confusing, but there is a subtle difference. So let's talk through that. So for example, if I have a database column, which is the date, normally what I do is I would specify this date type as a date, because that need to match your database column field. Okay. However, the MD type is a bit different. Let's take an example. When we have a payload with a date type coming in, and we want to display as a date, store as a date, display as a date, and accept the payload as a date format, but we actually want to store against the field, which is a string. Maybe because we have some specific requirements on the data warehouse because they need to accept the common format. These kind of things could be happening in a project. So in that case, you won't use a data type because your data type is not going to match the the database field type. Remember when we using the data type and MD field, they are normally looking at the metadata layer. So MD field is matching a metadata field and take the type of that field from the metadata. Doesn't have to match the database. Okay, so in that way we have a date from the payloads. We have a date to be displayed on the screen, but it doesn't have to be stored as stored into a date column on the database. The last one is the FKREF. So FKREF is basically a foreigner key reference. In that case, let's say this one is the primary contract and it's referred to a service agreement. So to make sure the reference is valid, we use this FKREF to add an additional layer of validation. And if a payload comes in where the contract doesn't exist, or the ID of that contract is not existing in any of the SAID, for example, the payload will get rejected. Okay? Right, some good practice when you are using these features. So first, you cannot contradict the physical field actual data type against the data type, as we just mentioned. Second, if used MD field on element, don't use a data type because they are essentially the same thing, but sometimes the MD fields give you a bit more flexibility. The third one, if you have mapped the element to a non-generic column using a map field, do not use data type. Actually, this is something I think the system will do for you. So when you are defining a field, if you create something from scratch, say map field to a particular field, and you save the schema, sometimes the data type will be populated if it's not a string. So you might have seen that before, but you can try yourself. The fourth one, if you want the system to validate the element is present and not blank, you can use require equal to true. Yeah, that's a very important feature as well in your modeling. And number 5, mark an element as private equal to true means you don't expose this to the BO. Okay, so this is a very interesting feature because sometimes some of the fields you still want to map it when you are writing a record, but you don't want to show that on the screen. So you make them as true. And also sometimes you say, I want to add an element value which you want to default to a certain value, and you don't want this to be shown on the screen as well. Sometimes they're just kind of utility fields, so you can use this field as well. Right, part 4, group and list. So what is a group? Let's look at the example on the right hand side. Okay, so this is a home address group with a list of attributes. So remember, what we have seen so far is we have a flattened BO schema of different elements. Although those elements, we can map them to the primary table or the child table. Now we are talking about, we want a structured schema. However, they might be mapped into different tables. primary table or the child table. So you can actually use this schema. They're actually different things because the schema of the BO is the business reference level, and that is how you are showing the data structure for the business. However, the backend, where we can see these map fields, later we'll talk about, we've seen the map child, and also later we'll see whether it's mapped to XML, the CLOB. So this is how the business element is mapped to the physical tables. So they are different concepts, but the schema is flexible enough to map them separately. So you can map single level elements into multiple level of tables, or you can have multiple level of elements into a single level table. Let's say in that way. So in this case, as you can see, it's using the type equal to group to declare the group level, and then you can have the elements within it. So next. Okay, so let's look at the list. So on the right hand side, we can see the seasonal address. In this case is a list and maps to a child table, which is the CI per address seasons. Okay, so list is like array, as I just said. You can have multiple occurrence, 0 to many, and within the list, each of the column in this case is mapped to a field in the child table. Normally, you will have one of the field as primary key, and that is normally mapped to the child table primary key. Okay, the physical child table primary key. So in that way, we can make sure all the records, if we are given a payload, all the records can be inserted from this list as individual rows in the child table. I would like to mention a use case for the group and the list. With the flexibility of the schema design, as we can see, you can have a single level schema mapped to multiple physical tables, and you can have multiple level of schema structure mapped to a single table. For example, using the CLOB, we can actually match the external system. Sometimes we need to make sure the structure of the payload matches the industry standard. For example, if we are modeling this as for a market message, we do need to make sure, the data structure in our system can be flexible enough to match the market message. So when you see the market message in XML format, for example, and some of the child is a single group, or some of the child is a list with 0 to many occurrence, now you know how you can model them. Right, so last topic, which is CLOB. Okay, so before we start, I would like to introduce this CLOB type. So it's actually a Oracle field type which contains large amount of text. So it's called characteristic large object type. In this case, actually, we use this to store a large amount of data. And normally these data, they are grouped in one functionality. So for example, a market message, as you can see here, and we use them to store the the group of elements together. You can see on the left hand side example here. So for example, we have a message with different attributes. We store everything in XML in one column called BO definition area in that case. And normally these attributes, they do need to be stored and eventually retrieved when we use it, but they in business term, they don't need to be queried, because if we do need it to be queried, we will store that in a different way, as we will see in the next slide. There are quite a lot of cases we have these CLOB columns to be mapped in different BOs. For example, the most common one is the fact records. So you have a fact data area column. In some of the MDM tables, you would actually have multiple columns mapped to the XML. So for example, the D1 initial measurement data. So that one would have pre VE data area, post VE data area, raw data area to store different level of meter reads. Right, so on the left hand side we can see two examples. One is to map to a CLOB using the map XML, and another one is a service agreement ID map to a characteristic where the characteristic look like FK reference characteristic. There is a golden rule. Well, there's actually two. The first one is when you're choosing which type of fields you want to map to, the decision is based on if you need to join an element in your query, it needs to go into your real column, which means it needs to go to the characteristic table. In that way, you can join them up. But the second rule is do not overuse characteristic, because it's quite often not just one characteristics will be involved in your query when you're doing let's say a business report. There could be multiple characteristics being used. However, most of these characteristic table, they also have effective date columns. So imagine if you want to have 10 different characteristics with most effective dated values, how big the query gonna end up with? So in those cases, I would suggest we think about a different solution. Maybe store that in the CLOB, and then we using a script to read the BO as a whole and then present the values. So there are different design decisions based on not only the nature of this field, but also how this field is being used in the business. Right, so that's all for today, and thank you very much. If you like the video and subscribe to it. If you think your friends or colleague will benefit from these videos, please ask them to join as well. See you next week.